Okay, so from now onwards you can have better visual of our video. So we buy a new camera just for your class. Yeah. No problem, but give the thank you in your feedback. Okay, so in the previous class we discussed about separable OD. By the way, those are on, those monitors. Okay. So in the previous class we discussed about the separable OD. That means the OD is where we can separate the X and Y. So that is separable OD. Okay. So there are certain ODs that cannot be separated. We cannot separate X and Y. If we separate them, we can just apply integration and solve it. But there are certain ODs that cannot be separable. We cannot separate X and Y. Okay? So those ODs are called something called exact ODs. Those ODs are called exact ODs. Okay. So in this chapter we are going to study two things. One is the exact OD. Another thing is called integrating factor. Integrating factor. There are two things we are going to study. Okay. So let's focus first about the exact OD. So today our focus will be exact OD, and then possibly in the next class our focus will come to the integrating factor. Okay. So let's understand what exactly this exact OD. Okay. Suppose I will write a OD like our focus is this one, exact OD. Let's focus this one, exact OD. Suppose I will write a OD y dash is equal to minus 2xy cube plus 2 divided by 3x square y square plus 8 e to the power 4y, something like that. I just randomly write something. Okay. So this is a OD, suppose I write. So now the problem is that can you separate this OD x and y separate? Is it possible? To look into this OD, it is very complex, looking like very complex one, and we cannot separate the x and y part. So this one is not a separable OD. Okay. So in that scenario, what we can do is that whatever this kind of ODs, this just like I wrote this one, what we can do, any ODs that is in the form y dash is equal to fx y in this form, we can convert this one into a form that is called, we can rewrite these ODs in the form m xy plus n xy y dash is equal to 0, or we can also rewrite this one as m xy dx plus n xy dy is equal to 0. So when we write this OD in this form, then we say the OD is called exact OD. Any OD that can be written in this particular form is called exact ODE. Okay? If you write the ODE in this particular form, this is called the exact ODE form. Now, I am not saying this is the exact ODE, this is the exact ODE form. Okay? Now, then the next question is whether this particular ODE is exact or not. This is the exact ODE form. In this form we are writing. This is the exact ODE form. Now the question is whether this ODE is exact or not. After writing the ODE in this form, whether this ODE is exact ODE or not. To do that, what we can do is that we try to find out dm by dy and dn by dx. So what is m and what is y? You have m is this one, so you need to calculate dm by dy, and what is here? dn, this is n, dn by dx. You have to calculate. Now if this dm by dy is equal to dn by dx, then this one, this ODE will be called exact ODE. So if this happens, this is called exact ODE. Okay? Okay? Now if dm by dy is not equal to dn by dx, then we can say it is not exact. First, you have given the ODE, you have to make the ODE into exact ODE form. Then you have to test whether the ODE is exact or not. How to check whether the ODE is exact or not? This is the way you can check whether it is exact or not. If it is not, then if they are not equal, then that is not exact ODE. Okay? Clear? Right? Now there are two questions. If it is not exact, what to do? If it is exact, what to do? Now, what is there that we have some method to solve the ODE to exact. If the ODE is exact, we have certain method to apply to solve the ODEs. That we are going to learn today. Okay? Now, if the ODE is not exact, then we have to do something. We have to do something to make the ODE exact. Are you getting me? Then we can solve the ODE applying the exact ODE solution method. Are you getting me? Are you getting me? Or confused? No, you should say yes or no. So as I mentioned, we are going to study two things. One is the exact ODE, another one is the integrating factor. This integrating factor will be applied when the ODE is not exact. Okay, so we will study that one later. So first, if the ODE is exact, then how to solve that ODE? So let's focus on that one. Okay. So now let's focus to solve this ODE. Okay. Okay, so we can write any OD in this particular form. Okay, let me explain you by writing for your reference. First order ODE, that is mxy dx plus nxy dy is equal to 0 is called exact ODE if the differential equation from mxy dx plus nxy dy is exact. That is, this form is differential of some function u x y. What is this u x y? This is the differential function, that is du is equal to du by dx plus du by dy dy. So this is the first order ODE. Let's say I will put, this is my equation 1. I'm saying this equation 1 is called exact ODE if the differential equation form, that is mdx and ndy is exact. That is, this form is differential. This form is differential. Okay, so I think I should remove this one, this sentence from here. It will be more appropriate. this form is differential of this of some function u x y. Then we can write the equation 1. Then the equation 1 can be written as du is equal to 0. So by integrating we get the general solution of 1. What is that? If we integrate this one, you will get how much? uxy is equal to c. Now if you compare, this is, let's say this is equation number 2. So if you compare this one, I will take another color, this m and du dx and n du dy. So comparing 1 and 2, we see that 1 has an exact differential equation if there is some function uxy such that du by dx is equal to m and du by dy is equal to n. So if you compare these two, equation 1 and equation 2, okay? So what you exactly get is this one. Let's say I can put this one is A and B. Now by partial differentiation, if you take the partial differentiation, so this one will be dm by dy is equal to d square u by dx dy. Similarly for this one, dn by dx is equal to d square u by dx dy. So by this way you can equate the dm by dy and dn by dx. So here we use this function u. Okay. So this function is actually called something called potential function. We are using the potential function to understand whether the ODE is exact or not, and we use that potential function to solve if it is an exact ODE. Okay, so let's understand what is exactly this potential function. If I want to define this function, potential function, the u I am writing here is actually called the potential function. So a function u, that is you can put uxy, is potential function for the differential equation m xy plus n xy y dash is equal to 0 on a region R of a plane. If for each xy in R, du by dx is equal to m and du by dy is equal to n. So that is what exactly the u is. You can also prove this one, that means how you can make dm by dy is equal to dn by dx. Are you getting it or any confusion? Yeah, from your face it seems like a lot of confusion. Is it so? Yes? Okay, if you have confusion, don't worry, you can still resolve it. How? When we apply this method to a problem, then you can realize what exactly it is, if you have still some confusion. Okay? Okay. So let's proceed. How exactly we can apply it? Okay? First, let's one example, simple example, and try to figure out how we can apply it. Okay? So let's take the example here that is called test the exactness and solution method for exact problem. Okay? There are two ways we can solve the exact ODE. Okay? So the first one, I am going to the one which is given in your book and which is the authorized one. There is some tricky method as well. So let's go with the original one. Okay. So first thing, let's take one example first. Example, here is a problem, let's say cos xy, okay, cos x plus y cosine x plus phi dx plus 3y square plus 2y plus cosine x plus y dy is equal to 0. So this is the ODE, given ODE. It is completely in the exact form, right? M dx plus n dy is equal to 0. That is the exact form. So that means I can say this one is my M and this one is my N, right? So test the exactness, calculate dm by dy and dn by dx, and tell me what is it. Yeah. dm by dy is how much? Minus sine x plus y. Is it okay? Because m is cosine x plus y. Yes or no? And dn by dx, so here is y is the constant, y has no value here, so it will be minus again sine x plus y. Yes, that means we can say dm by dy, dn by dx is equal, they both are equal. That means I can say it is an exact ODE. Is it making sense? Right? We test and we found the ODE is an exact ODE. Okay? Should we move forward? Okay. Now the next step is solving this one. If it is an exact OD, we already tested, and if it is an exact OD, so next step is we need to determine the potential function U. Okay? So the next step, so it is the step 1. This is step 2. In the step 2, we need to find out the general solution. It is called implicit general solution. We need to calculate. So how? If it is exact, the potential function uxy can be found by method of inspection or in the following view. Method of inspection means you have to try, hit and try, you have to check which one will be the appropriate one. Okay? You can choose one, then put that one. If it is satisfied, it's okay, then otherwise you can try another one. Another method is the following way. So we already saw the method here. We wrote du is equal to 0. The potential function so we found m is equal to cosine x plus y, and our n is this one. If we integrate with respect to x and y is regarded as a constant, then we can get the u is equal to m dx plus ky, where this k term is a constant of integration. So in the equation, if you look, so what we are trying to do is that we are trying to integrate this one, considering this term is a constant term. Okay? So u is mdx plus kc, where we are treating the y part is a constant. Okay? That implies we are getting cosine x plus y dx. So this is, sorry, I forgot to put the integration. Integrate ky. So this is giving us how much? The sine x plus y plus ky. This is our u. So ky is a constant. Yeah, any problem? If ky is a constant, to find, so our job is, we took ky as a constant, but we need to find out what is that constant value. To find ky, what we will do, we differentiate with respect to y. First we integrate with respect to x, where y part is constant. Now, to find out that constant, what we need to do, to find ky, differentiate with respect to y. So if we differentiate, it will be du by dy is equal to how much? Sin xy will become cos x plus y plus dk by dy. Are you okay? Now, what is this du by dy? Yeah, you guys have any confusion? Please let me know. Now tell me, what is this du by dy? What is du by dy? What is du by dy? We already defined du by dy is n and du by dx is m. So this is nothing but n. And what is n? What is n in your problem? This is your n. That implies it is how much? 3y square plus 2y plus cosine x plus y. That implies what you got here is this cosine x plus y plus dk by dy is equal to 3y square plus 2y plus cosine x plus y. Hello, please. This is very unfair. Talking using phone inside the class. Yeah. Please, if you have something important, please leave. Now you can easily see this part we can cut. This one and this one. What we left? We just left dk by dy is equal to 3y square plus 2y. Then by integrating both sides, by integration, we get k is equal to y cube plus y square plus c. Right? We got this is the k value, but our objective is to find out what is u. What is the u we have taken? Our u was, we have taken u was sin x plus y plus k. Right? That means sin x plus y plus y cube plus y square plus c. So u is equal to 0, right? This one is equal to, if u is equal to 0, we can just write, we can put this one is equal to, if this one is equal to 0, we can just move this one to the other side. You can make this one is equal to c. Yeah, any confusion? Got it? Clear? Now, please review this, the problem. If you analyze the concept using the problem, you can easily understand this one. Little bit tricky this one. Okay? But if you analyze it through the problem, you can easily understand this. Now this one is the original method by which we solve this one. There is another alternative method, that is a tricky method is there. You can also solve the same problem. So what is that? The alternative method, if I will write here, if the OD is given in this form, m dx plus n dy is equal to 0, so what we need to do is that apply to solve, apply this method, m xy dx integration plus n xy dy integration is equal to constant. Okay, but here is some condition applies. One condition is consider all y is equal to constant. Consider all the term related to y has to be constant. Only we will integrate the term with x. Okay? And in the n would be contain both x and y. In that case, what we can consider, any term that contain x should not be part of n. So that means the terms do not contain x. You just need to apply this method to solve easily without going for that potential function u, du, etc., etc. The simplest method. So I will show how this simple method will work in the next class. Okay? Thank you very much. See you in the next class.